Today, I'm spooked to start a 3-part series on math mysteries. We start by discussing Gabriel's horn. In 1643, Italian physicist and mathematician Evangelista Torricelli wrote about this object, although similar shapes had been found 300 years earlier by the French mathematician Nicole Oresme. The name refers to the Christian tradition that on Judgment Day, the Archangel Gabriel blows his horn. The way this horn-shaped figure is derived is by looking at the hyperbolic function 1 over x and putting the constraint of x being greater than 0, which results in this specific portion of the graph. The 2-dimensional figure is then revolved around the x-axis, resulting in the 3-dimensional horn. Since as x increases, or as you progress toward the right along the graph, the function decreases without bound, Gabriel's horn is an infinite object. The idea of infinity alone is enough to give you nightmares. But wait, there's more. This infinite object actually has a finite volume, but an infinite surface area. Don't believe me? We could walk through and explain every step of both of these proofs to show that the volume of the shape is equal to pi and the surface area is infinite, but that'd be a little too terrifying, even for this series. Gabriel's horn is also referred to as the painter's paradox. Why, you ask? Are you sure you can handle the answer? Okay, but remember, you asked for it. Because of its finite volume, you could theoretically fill the inside of the horn with a specific number of paint cans. More specifically, 3.14159265358979322384626433832795028841971. But if you were tasked with the fateful job of painting either the outside or inside of the horn, you'd paint it for the rest of your life and eventually die a failure. Is there a way out of this doomed fate? Well, if you ever find yourself with this seemingly impossible task before you, grab pi cans of paint, pour said cans into Gabriel's horn, empty the horn, and all that will be left is the paint residue covering every square inch of the interior. Which means you would have successfully painted an infinite object that has an infinite interior surface area with a finite amount of paint in a finite amount of time. Nicely done. Check back in next time, if you dare, when we continue this spooky series on math mysteries and discuss the golden ratio.